this is Mr. Bowen with another mathematical video. Today we're going to be discussing algebra and solving equations. By the end of this video, you'll have a better understanding of SADMEP and how to solve an equation with one variable. Before we get started, I wanted to share something with you, and that's from a book called A Survey of Mathematics by Vivian Shaw Groza. Starting here, the word algebra first appeared in the work Hisab al-Jabir around 825, and it literally meant reduction or restoration. Through this work, algebra came to mean the study of equations, the word being adopted by both Arabic and European scholars. One of the objectives of algebra is the solution of conditional equations, that is, to find the set of numbers from the universal set that make a conditional equation or open sentence true. Alright, so what does that mean? What does it mean to find the set of numbers from the universal set that makes a conditional equation or open sentence true? Well, let's take a look at that right now. Here we have a number sentence. We have an equation right before us. 52 equals 4y minus 16. Now, what we're trying to do is we're trying to find the number or the set of numbers that for y, for the value y, that make this a true statement. And we can do that using algebra and using inverse operations. But before we even start with any of that, let's pick a number and let y equal it. Let's say y equals 0. If we choose 0 for the value of y, does that make this a true statement? Let's find out. If we replace y with 0, then there's a hidden multiplication happening here between 4 and y. So this would be 4 times 0 minus 16. According to PEMDAS, we would do this multiplication here first. 4 times 0 is 0 minus 16. 52 equals that. 0 minus 16 is negative 16. And we end with 52 equals negative 16. And we're going to stop here because 52 does not equal negative 16. It is not equal to that. Meaning that for the selection of the number 0 for y, this is not a true statement. Alright? So selecting 0 does not work for y. But there is indeed a number that does work. And that's what we're going to go over today. We're going to find the number that can be y that makes this a true statement. Let's take a moment to discuss this over here. SADMEP, or, well, pronounced SADMEP. Does this look familiar at all? If you take a look at it, it will, because this is actually PEMDAS written in reverse. So, S stands for subtraction, A for addition, D division, M multiplication, E exponents, and P parentheses. Why are we using SADMEP here instead of PEMDAS? Well, in order to solve for y, in order to determine what y is for this equation, we're going to use inverse operations. And I will tell you what those inverse operations are right down here. For every operation that exists in mathematics, there exists its opposite, or its inverse. Alright? So here would be the original operation, and here we'll have its opposite, the inverse operation. Let's start with the operation of addition. The inverse of addition is subtraction. The inverse of subtraction, well, that would be addition. Multiplication is division, and the opposite of division is multiplication. Now there are other operations that can happen in mathematics we're not going to be reviewing those now. We will touch on those in the future. Let's take a look at our problem and see how we apply SADMEP to it, how we apply these inverse operations. In our problem, we have 52 equals 4y minus 16. Are there any exponents or parentheses in this problem? No. Let's get rid of those for now. We aren't going to be using exponents or parentheses in this problem. Let's see what else we can eliminate. 4y minus 16. Do we have any subtraction in the problem? Yes, we do. We are subtracting 16. Now, that doesn't mean that we're going to be using subtraction as an inverse operation to solve our problem, because the inverse of this subtraction is addition. So we will not be using any subtraction. Last, 4y. This implies that there is a hidden multiplication between 4 and y here. Thus, 4 times y is the operation happening. The inverse of multiplication is division. We will not be using multiplication to solve this problem. We will be using division because division is the inverse of multiplication. So what are we left with? Well, according to our SADMEP, all we have left is A and D. And this will happen in this order: addition, and then division. Let's take a look at what we can add, being our first step. Well, the subtraction was centered around happening to this minus 16 here. So we are going to perform an inverse operation of addition to both sides of the equation. As I do this, you'll notice for this equation, I am lining up like terms. Minus 16, or 16, is a like term to 52. Neither of them have any variables attached to them through multiplication, so I can add these terms together. Minus 16 plus 16? Well, this is one of the things that we're shooting for as we apply our inverse operations. This, negative 16 plus 16, is going to evaluate to 0. And that's what we want. Let's put a line right here, just dividing both sides of our equation. We're going to bring down this 4y plus 0. 52 plus 16 is 68. And now we are left with 68 equals 4y. Now, we have done all the addition that we have to solve this problem. We are going to apply our second inverse operation of division. Let me bring this down a little bit and rewrite it so that it's easier to look at. We have 68 equals 4y plus 0, or just 4y. Adding 0 isn't going to change anything, so it's just 68 equals 4y. The operation that was happening between 4 and y was multiplication. The inverse of that is division. Let's divide both sides by 4. All right. 4y divided by 4. Well, that is just going to be y. Right? 4 divided by 4 is 1. 1 times y is just y. We're left with y. Now, 68 divided by 4? Well, let's think about that for a second. 4 times 5 is 20. 4 times 10 would be 40. 4 times 15 would be 60. So this must be 17. 17 is equal to y. That last step we took, dividing both sides by 4, took care of the division for our problem. Now, per our mathematics, per what we have done here, we have determined that 17 is equal to y. However, what if we're not convinced? What if we don't necessarily know? Maybe we made a mistake somewhere, or maybe we're just, for the first time, solving equations using inverse operations. You want to make sure that this is actually a true statement. Well, we can do that. Let's go back to our original equation. 52 equals 4y minus 16. According to our inverse operations and our math, we say that y is equal to 17. This means that this is the only number that we can plug in for y that will make this a true statement. Let's see if that's true. 52 equals 4 times 17, replacing y with 17, minus 16. All right. 17 times 4, well, I don't know that off the top of my head, but we can find out, can't we? That would be 68. This would be 68 minus 16. 52 equals 68 minus 16. 68 minus 16, well, I know what it is off the top of my head, but let's just make sure that you can see where this comes from. 68 minus 16, 8 minus 6 is 2, 6 minus 1 is 5. 68 minus 16 is, in fact, 52. Now, does 52 equal 52? It does. And thus we have shown, through inverse operations and through proof of plugging in 17 for y, that in fact 17 is the answer. 17 is the solution for y for this equation. Let's take a look at another problem that we can apply SADMEP to. We have an equation here. We want to solve for w. And we're not just going to guess, we're going to apply some mathematical reasoning, some inverse operations that are going to help us determine exactly what it is without guessing. First, let's take a look at our problem. Do we have any exponents or parentheses to tackle? No, we do not. I'm going to cross these out. We don't need these right now. Next, I see that we have subtraction happening here. We won't be using subtraction in this problem. And I see that we have multiplication here. We won't be using any multiplication to solve this problem. Why? Well, we're only going to be using the inverse operations of subtraction and of multiplication, which are addition and division. All right, so step 1 is here, and step 2 will be here. Step 1 is addition. Let's set up another nice line right here on this equals, because whatever we do to one side of the equation, we have to do to the other. Okay? Now, step 1, addition. Let's look at what we're adding. We're going to be adding 11 to both sides of this equation. Lining these up as like terms. Negative 11 plus 11. Well, the entire reason we're doing this is because we want to get 0 here. All right. And on this side, 69 plus 11, that is 80. All right. 4w minus 0 equals 80. Well, subtracting 0 doesn't do anything to this at all, so 4w equals 80. That takes care of step 1, which was addition. Step 2, division. All right. What are we going to divide by? Well, 4w means 4 multiplied by w. We want to undo this multiplication with division. So let's divide both sides of this equation by 4. 4w divided by 4 would just be w, because 4 divided by 4 is 1. 1 times w is just w. And 80 divided by 4, well, 4 times 10 is 40, so 4 times 20 is equal to 80. So 80 divided by 4 is, in fact, 20. Next. Well, you could say, I'm done, I don't want to do any more. But let's say you're taking that big test right now and you really want to pass it. You want to make sure you did everything correctly. It's okay to go back and check your answer. And we can do that. All right, we can plug 20 in to our equation where w was originally, and if we get a true statement, then we know that w does in fact equal 20. So let's do that. 4 times 20, replacing this w with this 20, minus 11 equals 69. Let's see if this is true. 4 times 20 is 80. We still have that subtraction of 11 happening. That is equal to 69. 80 minus 11. Well, let's see what that is. I know what it is, but let's see. Borrow. 10 minus 1 is 9. 7 minus 1 is 69. On this side of the equation, we're left with 69 equals, oh, and nothing over here changed. 69 equals 69. That is true. All right. Very good. This means that W does in fact equal 20. Let's take a look at one last problem, all right? One last problem using SADMEP, using inverse operations. Let's go. So, 68 is equal to 3 times u plus 11. Once again, right now we don't have any exponents or parentheses here. Don't worry, in the future we will, and it's going to get fun once we have those. For now, SADMEP. Looking at this problem, the operation happening between 3u and 11 is addition. So we are not going to be using addition to solve this problem. Likewise, once more, 3u, well, the operation happening between 3 and u is multiplication. We will not be using multiplication to solve this problem. That leaves us with the operations of subtraction and then division. Let's get started. Let's subtract 11 from both sides of this equation. All right, I'm going to draw my line here. 11 minus 11 is 0, and that's what we want. Bring down that 3u. 68 minus 11 is 57, and that is equal to 3u plus 0. This plus 0 will just go away. Adding 0 doesn't do anything to change that side of the equation. And that is the subtraction. Next, division. Let's divide both sides of this equation by 3. We are undoing, using the inverse operation of division, this multiplication that was happening between 3 and u. Whatever we do to one side, we have to do to the other. It's all about balance. 3u divided by u? Well, that's going to be just u. And 57 divided by 3. I know off the top of my head that 3 times 20 is equal to 60. So this must be 19. All right? Don't believe me? We can do that over here real quick. 57 divided by 3. 3 goes into 5 once. Bring down the 3. 1 times 3 is 3. 5 minus 3 is 2. Bring down the 7. How many times does 3 go into 27? Well, that's 9 times. 9 times 3 is 27. And 27 minus 27 is 0. Okay? Thus, 57 divided by 3 is 19. All right. Well, once again, we're taking a test. We want to make sure, we just did this, cross that out. We want to make sure that we got this answer correct. Maybe I messed up on my division over here. Maybe one of my inverse operations wasn't lined up very nicely. We'll see. Let's test. We can test to see if 19 is in fact equal to u. 68 equals 3 times 19, replacing u with 19, plus 11. All right, 3 times 19. Well, looking back at what I have over here, actually, 3 times 19 is 57, right? Well, we can test that. 19 times 3. 9 times 3 is 27. 1 times 3 is 3, plus 2 is 5, 57. All right, so we did that correctly. This is 57 plus 11. All right, 57 plus 11, 68. 68 does in fact equal 68. Thus, we know that 19 does in fact equal you. All right, thank you. By now you should be feeling pretty comfortable with solving two-step equations using SADMEP. Here, I'm going to not solve this problem right now. I'm going to leave it to you to solve. X divided by 3 plus 4 equals 13. It's a little different than some of the others we just went over. So if you're feeling up to a challenge, try to tackle this problem. Alright, that's going to wrap it up for this video. If you have any questions, comments, or concerns, please let me know. Other than that, I hope you had fun, and I hope you have a wonderful and a happy mathematical day. Thank you.